Welcome back to the GCSE Maths Pro YouTube channel. Today we're going to be looking at the third part of the inequalities topic, which is inequalities regions on a graph. This video, and also the one that follows, which is solving quadratic inequalities, is for higher tier only. Okay, so if you're doing foundation tier, you only need to watch the first 2 videos and stop there. So what are we referring to when we say inequalities regions or regions inequalities or inequalities on a graph? What are we actually talking about? Well, as you can see here, you will likely see this type of setup where you've got obviously a grid and you've got 3 inequalities in front of you. These are all linear inequalities, okay? They're only just x to the power of 1, aren't they? They're just linear inequalities. But now you can see that some of them also have both y and x because we're relating them to graphs now. What you'll need to do is be really happy with plotting straight line graphs for this topic to make a lot of sense, okay? So we're going to go through how to plot straight line graphs really quickly, but make sure you're happy to do that anyway. We're not going to go through it in much depth. So the question they normally ask is, on the grid, shade the region that satisfies all these inequalities and then label the region R. What that means is, okay, we've got 3 inequalities. We need to draw those as if they are lines, okay, straight line graphs. To draw the 3 lines, then come back and look at the actual inequalities, and we need to figure out by process of elimination which region on the grid do we need to shade in, which bit would satisfy all 3. Okay? So, as I say with most of my videos, if you are able to just draw 3 straight lines, that will already give you 2 out of the 3 marks. Okay? So if you're not sure about the inequality part, don't leave it blank. Make sure you know how to draw the straight lines, and then, if in doubt, just colour in any part of the grid, to be honest. Okay, but let's go through it so you do know how to do it. Hopefully, and I'd say normally, you'll be given ideally one inequality that doesn't have both x and y in it, okay? It might be just x or just y, it depends. But what I would say is for the first bit, ignore the inequality symbols and rewrite it with an equals. Okay, that's x equals 4. Where is that line on this grid? Don't make the really common mistake of thinking, well, I know that the x-axis is horizontal, so I just find 4 and I go horizontally. It's so easy to make that mistake, but that's 4 on the y-axis, isn't it? That's not where x is 4. Where x is 4 is obviously here, and as a line, it's vertical the whole way along here. What we're saying is we don't care what y is, x must always be 4. Okay, so that's this vertical line here, so don't make that mistake, it's quite easy to. So I'm just going to draw a line straight down here. Now I'm going to use a dashed line just because it's not got the equals to bit as well, has it? Sometimes they're fussy about this, sometimes they're not, but just in case, I'll put a dashed line. Okay, that's fine. Again, ignore the actual inequalities as such, we're just going to put that line there. Now the inequalities that have both x and y, they are straight lines, but they're going to be some kind of diagonal line, okay? So it's a bit more difficult to plot. But what I want you to refer back to is straight line graphs are normally in this format, aren't they? Y equals mx plus c. Now remember, the plus c is the y-intercept, isn't it? That's where it crosses the y-axis. And because these are straight lines, normally when you plot a graph, you do an xy table, wouldn't you? What I mean by that is something like this. XY table, and then you have values of x, and you then work out the values of y and plot the coordinates. You can do that. However, because it's a straight line, we only actually need to do that twice. We only need to find 2 different coordinates, and then get your ruler and just draw a line through it. Okay, you don't need to plot every single one of these coordinates, right? That would take way too long. So you can put it in the format of an XY table if that's helpful, but we only need 2 coordinates. The other thing is if you've got, if it is a calculator exam and you know how to find the table on your calculator very quickly, you can also do that, okay? So let's say we're going to take our second inequality, y equals x. Again, forget about the inequality symbol, we're just going to put equals. This one's quite an easy one to do anyway, because whatever y is, x is, and whatever x is, y is, so you could probably just plot that straight away. But the way that I would do it is I would say, one of your coordinates, just take it as the y-intercept. That's so easy because that's where x is 0, isn't it? The y-axis is where x is 0, and the intercept is whatever this number at the end is. Okay, this one doesn't have one, does it? Clearly then that's just 0, isn't it? So my coordinates, I've got 0, 0. That makes sense because whatever y is, x is the same. So I've got this coordinate here, Okay, and then just choose any other coordinate. Make sure it's not too big that it ends up going off the grid maybe, but also don't choose 1 because that's quite hard to then use your ruler to draw accurately a line through those. So for this one, because I know y is the same as x, I'm probably just going to choose like 5. When x is 5, y is also 5, isn't it? They are the same. That's that equation. Now, I'm just going to get my ruler and draw a line. Again, because it's not equal to, it's just less than, I'm going to use a dotted line. And just use a ruler, obviously extend it the whole way through the graph, right? Don't just stop where the coordinates are. And make sure, you might want to label it, we don't want to forget which is which, okay? I'm going to label this one as y is greater than x. And now do the same with the second one. So y equals 2x plus 2. You don't have to draw the xy table if you don't want to, but some people find it easy. So my first one, I'm going to use the y-intercept. Well, I know where x is 0, y is just going to be 2, isn't it? That is the y-intercept, so 0, 2. And then choose another coordinate. This is where I say again, be careful, because obviously if I choose 5 for x, if I substitute that in, 5 times 2 is 10, plus 2 is 12. Well, that's way beyond my grid, isn't it? So while I might not want to choose one super close, I might choose 2. When x is 2, I basically have to substitute that in, don't I? So y is 2 multiplied by 2 plus 2. Okay, they're all 2s. 2 times 2 is 4. Plus another 2 is 6, isn't it? So y is 6. Okay, there's my other coordinate. 2, 6. So 2 along, 6 up. Luckily that's not gone too far out. And now, again, I'm going to join it with a dotted line, or a dashed line, because it's not exactly equal to, is it? It's just less than that. Okay, and label that one as well, just so we know which is which. Y is less than 2x plus 2. If you even just get this far, this is just plotting straight line graphs, you're going to get 2 out of 3 marks. That's the majority of the marks, okay? The last bit is to see which is the regions. What I mean by that is it, this shape here, this bit here. There's so many, you can see there's a few different regions. Which region satisfies all of these inequalities? That's the tricky bit. So like I said, if you get to this point and you're in the exam and you forget how to interpret the inequalities, don't leave it blank, just colour in whichever region you think, because you might get it right. A little secret though, I wouldn't say rely on this. Obviously, I'm not recommending you rely on this, but if you are just in the exam, you're already there, you can't remember, shade in this bit here. I know it doesn't look like a triangle, but most of the time it creates a triangle between the 3 of the lines, okay? Shade in the bit in the middle. It's not always that. However, a lot of the time it is the bit in the middle. Only do that if you don't remember what else to do, okay? It's better than leaving it blank. However, this is how we're going to interpret it. So we're going to use process of elimination, okay? We're going to go through one by one, and we're going to figure out which parts of the graph can we basically eliminate, which bits are not going to satisfy all of them. So I would again start off with the first one because that's the easiest one to interpret, isn't it? It's saying x is less than 4. X is horizontal, isn't it, across? So what we're saying is x can be anything less than 4. Well, that's saying anything to the left of that line, isn't it? So what we're saying is we can't have this bit here. That does not satisfy that inequality. So we've already eliminated the right-hand side. Now, it's quite hard to do this when you're in the exam, but I'm just going to highlight the bits that we want to keep, okay? So let's call this one yellow. The part of the grid that would satisfy just that one is everything to the left, isn't it? We've just said that anything where the x coordinates are below 4 or less than 4. Now, I'm not saying you would do this in your exam, right? Because obviously you need to shade only the bit that they want, but I'm just going to do this so you can see where they all overlap, and that'll be our final answer. So that's the first one. Okay, let's try the next one. The ones where you've got both x and y, that's where it gets a little bit tricky to interpret, okay? So what I'm going to do is I'm going to have it over here. Y is greater than x. Keep the y, but imagine whatever is on the other side with the x's as the line, okay? Imagine it as that. Now, y is vertical, isn't it? So what we want to think of here is, of our line, which is this diagonal one here, are we referring to the fact that the y, as in vertically, is above the line or below the line? Is it greater than or less than? In this case, you can see the inequality symbol is facing the y, isn't it? So what that says is y is greater than the line. So I interpret that as, I want the section of the grid that is above that line. That's why you need to write down which line is which, because otherwise you can easily forget. So for this green one, I'm going to say the bit that satisfies that is anything above, if I can colour it in nicely, that would be great. Anything above this line, isn't it? We don't want anything below the line because y is greater than the line. So vertically above. Okay, and then just do that with the final one because it's the exact same thing. So let's do this one as orange. And we've got y is less than the 2x plus 2. And again, just think of the 2x plus 2 as the line. So vertically, we're saying y is less than the line or below the line, which is this one here, isn't it? So in terms of our orange highlighter, it's saying anything below that line. Anything vertically below the line. Okay, now I know it's not massively clear to see, but basically what we're saying is we want to now use the bit where the highlighters, all three colours overlap. That's the area that these three inequalities are all satisfied. Okay, so I don't know if you can see that, but it's basically this bit in the middle, isn't it? Like I said, a lot of the time it is this bit in the middle, to be honest. It's this bit here. Okay? So as I said, in your exam, you're not going to go and highlight all of the, all of them individually, but mentally in your head, you're going to go, right, okay, the first one doesn't include this bit, the second one doesn't include anything below, the third one doesn't include anything above, right? So the bit that satisfies all three inequalities is this bit in the middle, and obviously you have to label the region R. Okay, so I've gone into a lot of depth with that in terms of the highlighters. The next one, I'm not going to use the highlighters as such, just so you can see how I would literally obviously leave it in the exam, just shade in the bit that you need. But as I said, that bit can be quite complicated, and it's only one extra mark. Okay, so you've got to figure out, is it worth my time? Not only now in terms of revision, but in terms of my exam. Is it worth my time if I find it, if it doesn't just naturally kind of make sense to try and interpret the inequalities when I know I can just successfully draw the three lines and then I can just kind of guess which part of the grid to shade in, because either way it's just one mark, isn't it? This is where you've got to think tactfully and like being really strategic. What is worth my time in the exam? What is not? It is not worth your time in the exam to spend 5 minutes trying to figure out which area to colour in. It's one mark. If you can figure it out within 1 minute, do it. If you can't, just colour in any part that you think you should go with, okay? I would focus on making sure you are happy with drawing the three lines successfully. That's the more important bit because that will give you the 2 marks. Okay? Okay, now it's basically the same again. So, the first one we have here, on the grid, shade the region that satisfies all these inequalities. Label the region R. So we've got 3 inequalities again. 2 of them have X and Y and 1 of them is just Y. So that's the easiest one to start with, isn't it? So I've got here, imagine it as equals. So where is the line y is equal to -5? Well, again, don't get mixed up and think, oh, y is vertical, so it's a vertical line at -5. No, that's where x is -5, isn't it? So find -5 on the y-axis, which is here. And it doesn't matter what x is, anywhere along this horizontal line, y is -5, isn't it? Now, do you see how this one has an equals symbol as well? Y is greater than or equal to. That's when we're going to use the solid line. So we use our dash line when it's just less than or greater than. And we used the solid line when we've got equals to as well. Okay, that's the difference. I don't think they're normally that fussy. If your question, like the previous one, is all the same thing, it's all either just less than or greater than, or it's all either with the equals, it probably doesn't matter. But if you've got a mixture, quite clearly a mixture of the 2 different types of symbols, of one with equals and one not, then yes, it's probably very specific that you should do some dash lines and then some solid lines, okay? So that one's really easy. Now, onto the next one is a little bit trickier, because as we said, straight line graphs are normally in this format, aren't they? Y equals mx plus c. And if I write this one with the equals, x plus y equals 3, we need y to be the subject, don't we, ideally? That's the easiest way. So if you get something like this where y is currently not the subject, it's not on its own, just rearrange it. So in that case, I just need to minus the x, don't I? We've got y equals minus x plus 3. I'm just writing the x there at the front because then it's the same format as this, okay? Now it's the same thing. Okay, now it's the same thing. So I'm going to plot it by, I need to choose 2 coordinates. Obviously, I'm going to use the y-intercept because that's the easiest part, isn't it? the y-intercept, I know that when x is 0, y is whatever that number is at the end. So my xy table, when x is 0, y in this case is positive 3, isn't it? I don't even need to substitute it in. It just tells me that. So 0, 3, okay? Then choose another one. Again, make sure it doesn't end up with a y value that goes outside of the grid. So I could choose 5. Let's say when x is 5, I need to substitute it in. So y equals minus 5 plus 3. Well, that's minus 2, isn't it? So those are my two coordinates, 0, 3, and 5 minus 2. Okay, I'm going through this bit quite quickly, as I said, because drawing straight line graphs is a different topic technically, isn't it? So I'm not going into detail about that part of it. Now I've got my two coordinates, I can draw my line with the ruler straight through it. This one is less than, it's not got the equals to, so I'm going to use the dotted line, okay? So just draw a line straight through, make sure it's accurately through, and the whole way through the grid. You might also want to note which one that one is. Now I'll just repeat the same for the last one. That one we don't need to rearrange though, do we? That's easier. So I've got y equals x minus 1, my x, y table. So again, I can just use the y-intercept. When x is 0, I know that y is minus 1. That's easy. And then just choose another value. I might choose 5 again. So when x is 5, substitute that in. 5 minus 1, well, that's 4, isn't it? So my coordinate there is 5, 4. 5 along, 4 up here. And again, I'm going to use a dotted line because it's not equal to, it's just less than, isn't it? Okay, draw that through as accurately as you can the whole way through the grid. There we go. That will be 2 out of the 3 marks already. Now we know which line is which. Okay, now the last bit, which is the final mark, is the interpretation. The first one's easy, isn't it? Because we're saying, okay, y is vertical. Here we're saying y is greater than or equal to minus 5, so it's anything above, isn't it? So we've eliminated all of this. We're not including this. Okay, so kind of mentally I'm noting that down. So I want anything above. I could draw little arrows, couldn't I guess? Little arrows here. I'm not going to highlight it. You know, you note it down however you want to. Might even use your pencil and then you can rub it out afterwards. Okay, so we've done that one. Then the next one, I'm going to take it as the rearranged version, but obviously rewrite it with my correct symbol. The symbol hasn't changed direction. We haven't flipped it because we haven't divided by or multiplied by negative, have we? So we've got that. And again, as I said, when it's got x and y, have y on one side and the other side with the x, think of it as the line. So this is my line. So vertically speaking, is y, are we talking about above or below the line? Are we talking about something greater than the line or less than the line? So in this case, y is less than the line, isn't it? The inequality symbol is facing the line, so that's the greater thing. So what we're saying is vertically, we're saying if y is less than the line, we want below the line. So we want below this line, which is why it's important to remember which line is which. So we want everything below that line. Anything above this line, eliminated, okay? So we've got that, and now the last one, we don't need to rearrange that. So y is less than x minus 1, so y is, again, change that for the line. Same thing, y is less than the line. It is below this line here, isn't it? So now we're talking about anything below this line. So now that we've got all 3 of them interpreted individually, what you need to do is find the region, this one hopefully is a bit more clear, a region where all 3 of them are satisfied. And what I mean by that is, can you see this bit in the middle? It's almost a triangle if we were to extend it. This bit satisfies all 3 of them, doesn't it? This bit here. Do you see that? I think hopefully that's a bit more clear than the highlighter version previously. Okay, because this bit up here, this region is only satisfied really by 2 of the inequalities, so not the third one. This one here is only satisfied by, again, 2 of them, not the second one here. The bit at the top is only satisfied by this one down here, so we are colouring in this bit in the middle. Okay, and obviously you wouldn't have any of this. The bit that you would show in your exam is just shade it in and very clearly label it R. Okay, so R. That's how you would actually leave it. All right, obviously not with colour, you would use your pencil. And from here, we're basically just now going to repeat the same thing over and over again. Draw the 3 lines, then try and interpret which area satisfies all 3 of the inequalities. So, as I said, we're going to start off with the easier one, which is just y equals 2. Okay, so where y equals 2, we find 2 on the y-axis, and it's across. Remember, it's across, and we want a dashed line. Okay, easy as that. Next one. We've got y equals 3 minus a half x. Okay, don't necessarily need to rearrange it. However, it is written in a different order. Okay, you can see the x bit is at the end, isn't it? And the 3 is there. So don't get mixed up. You can rewrite this if you want as put the x first. So y equals minus a half x plus 3. That might be a bit clearer, but hopefully you'll just recognise it anyway. XY table, when x is 0, we know that this is the intercept, isn't it? 3. So I've got 0, 3. And choose another value of x. Because we're going to half it, I'm probably going to choose an even number, so 4. So when x is 4, sub it in. Y equals minus a half times 4 plus 3. So half times 4 is just 2, isn't it? It's like dividing 4 by 2. Minus 2 plus 3. Minus 2 plus 3 is 1. Obviously, if you've got a calculator, if this is in a calculator exam, it'll be much easier. So 4 along, 1 up here. Now this one's got the equal symbol, so I am going to do a solid line and try and extend it through the whole thing. Looks pretty accurate. Okay, and then I'm going to obviously draw a little arrow so I know which is which. And then we do the final one. We also don't need to rearrange that one, do we? That one's quite nice. So xy table, when x is 0, y is just the y-intercept, which is 1. So 0, 1. Choose another value. Now be careful because this one we are timesing it by 4, so we don't want it to go too far outside. So I probably will just choose 1 in this case. So when x is 1, y is 4 times 1 plus 1. So 4 plus 1 is 5. That's still within our grid. So 1 across, 5 up. Again, this is a solid line, isn't it? Because it is equal to as well. See how accurately I can draw this? Obviously, it's much easier with a ruler, literally, because you can line it up properly. About there, isn't it? There we go. And that one is this one. Okay, you can see this one has created a little triangle in the middle. So as I was saying before, if you get to this point, you've drawn them all well, but you're not really sure, you've completely forgotten how to interpret it, I would recommend probably colouring in the triangle in the middle. Because 80% of the time I would say it is that bit. So there's a good chance you'll get it right if you've forgotten. Okay, if you've forgotten or you feel like, do you know what, I didn't really get the bit about interpreting the inequalities, it's going to take me more than 1 minute to figure it out, so I'm just going to colour that bit in, okay? But hopefully after this video you'll be able to interpret it pretty well. So we've drawn our lines, now we're going to interpret. The first one's really easy, isn't it? Y is less than 2, so we're saying about below 2. Okay, well in this case we've already eliminated that triangle, haven't we actually? We want anything below this point. Okay, and then the next one, as I said, rewrite it with the line. So we've got y, I'm just going to copy it down here so we can see it. And then, as I said, instead of the 3 minus a half x, write it as the line. That's much easier. So vertically speaking, is y greater than or less than the line? Is it above or below the line? Well, the inequality symbol is facing the y, so the y is greater, isn't it? So we're referring to the part above the line. Now that line was this one here, wasn't it? So referring to all of this. Now you can already kind of see what is happening here. We've kind of already narrowed it down to this bit here already, haven't we? Okay, and the last one we need to check was y is less than or equal to 4x plus 1, so replace that with the line. You don't have to write this down as such, but you know, in your head, just think of it as the line. So vertically speaking, y is less than the line. It's below that line, isn't it? So this one here, we want everything below that line. So below this line. Okay. Now I know this one doesn't look very clear. All right, I realise that doesn't look very clear, but we've already said it has to be below this line here. So we've already, if I rub it out, we've already eliminated this part up here, haven't we, anyway? It's to be anything less than that vertical line there. Let me try and rub that out. Okay, you might do this with your pencil, just go through and rub it out, literally. And we said it has to be above this line here. So anything less than that is gone as well. And this line, it was below, wasn't it? Which this side of it does satisfy that. So the part that we're referring to is this bit. Okay, so like I said, it's not always the triangle in the middle, but if you are really stuck, it's a good bet. That is R. Okay. Okay, so we've gone through how you would do it. Now they could ask you a question where they've given it to you already drawn and you have to then go backwards and do the reverse and find out what the inequalities were originally. So it says here, write down the 3 inequalities that define the shaded region. Okay, well, I'm going to start off with, obviously, if you've got any vertical or horizontal lines. They're the easiest, aren't they? So let's just look at this horizontal one. Again, don't get mixed up and think, oh, that's the X one because it's horizontal. No, it is at 3 on the y-axis, isn't it? The whole way along, it's 3. So that one is, just as a number, y equals 3. That's that line, isn't it? We'll make it into an inequality in a minute, but that's just the line. Then we've also got a vertical one. So again, don't get mixed up and think it's y. It's actually at -2 on the x, isn't it? The whole way along this line is -2 on the x-axis. So as a line, that's x equals -2. And finally, obviously, the trickier one is the diagonal, isn't it? Because we know it's going to be x and y. However, we do know we're going to have y equals mx plus c, okay? And if you remember straight line graphs, we need c as the y-intercept and m as the gradient. Now, because we can see it in front of us, the y-intercept is the -2 in this case, isn't it? So I can just write that down immediately. Y equals something x minus 2. Okay, now I just need the gradient. The way that we find the gradient, and again, this is basically straight line graphs as a topic, so I'm not going into a huge amount of detail as to how we're going to do this, right? But check out those videos if you want to see how to find the gradient from a graph. It's effectively the m, which is the gradient, is the change in y over the change in x, isn't it? So you can just have a look, either choose 2 coordinates, subtract them, or you can just literally count some squares. So this is an exact coordinate, and so is this. So the change in y is 2 up, isn't it? Change in x is 2 along. So 2 divided by 2 is 1. And it's positive, isn't it? It's going upwards. So the gradient is 1. So actually, I don't even need to write anything in front of the x. Don't need to write 1x, do I? It's not helpful. So that's my equation of that line. Okay, so now we've got the lines, we just need to write them as inequalities. So change the symbols into inequality symbols. They're all solid lines, so they're going to be less than or equal to or greater than or equal to, aren't they? I would again start with the horizontal and vertical ones because they're quite easy, aren't they? So let's say where y was equal to 3 is this line here, isn't it? Across y equals 3. The shaded bit is below that, isn't it? Because we're talking about y, we're talking about vertically. It's below that, isn't it? So it's where y is less than 3. Okay, so we've got y is less than 3. That's pretty easy, isn't it? And then let's do the next one, which is the vertical one, which was quite easy as well. So this line was x equals -2. So because x is a horizontal axis and the shaded region is to the right, isn't it? It's going that way of this line. So we're saying x is greater than -2, aren't we? X is greater than -2. And finally, the one that's a bit more complicated, which we had here, y equals x minus 2. But think about it the same way as we just said, y equals the line. Are we talking about the shaded region being above the line, vertically above or vertically below? Well, it's above, isn't it? It's above the diagonal line. So y is greater than the line. So I'm going to write it as y is greater than x minus 2. Now, as I said, they're all solid lines, so just add in your equals to symbol as well. And that's it, there's your answer. Okay, same question again. A little bit harder though, because can you see we've got 2 diagonal lines, not just 1. Okay, so write down the 3 inequalities that define the shaded region. Well, let's first define the actual lines themselves, then we'll deal with the regions. So the easiest one is either a vertical or a horizontal one, which the vertical one here is at x is 2. So I've got x equals 2. We'll deal with the inequality later. Now we've got 2 diagonal ones. So let's use this top one first. As we said before, it's going to be y equals mx plus c, isn't it? Now you can find the plus c, the y-intercept, by just looking. Okay, that one's at +1, isn't it? So I've got y equals something x plus 1. And then the gradient, which is the m, we said was the change in y over the change in x. So just find two coordinates. That one's an exact one. Where else is an exact one? Here. So I've gone 3 across and 1 up. So obviously y at the top and x at the bottom. 1 divided by 3, that's just the most simplified it can be, isn't it? Leave it as a fraction. Okay, we've got y equals a third x plus 1. That's that one. Now do the exact same thing with the second diagonal line, the one below. So we know it's going to be y equals something x, and then let's have a look at our y-intercept, minus 2. So I can write that in immediately. Something x minus 2, and again I want to find my gradient, which is the m, change in y over change in x, so I'm going to use minus 2, and this one's also exact, isn't it? So 2 along, 2 up. 2 divided by 2 is just 1, positive as well, it's going upwards. So actually that one is just x minus 2, isn't it? 1x minus 2, so let me move that across. X minus 2. Okay, so we've actually defined all of our lines. However, now we need to write them as inequalities. So starting off with the first one, which is the easiest bit. The shaded region is to the right of that line, isn't it? So we're saying where x is anything bigger than 2, isn't it? X is greater than 2. Okay, so x is greater than 2. That's that one, pretty easy. Now the other two, remember, we're referring to it as vertically. Are we referring to the shaded region as above or below the line? So let's say this one here, which we know as y equals a third x plus 1. The shaded region is below it, isn't it? It's below it. So y is less than the line. The line being the bit on the other side of the inequality, okay? So it's less than that. And lastly, this one here is the one below, okay, the line below. The shaded region is above that line, isn't it? It's above it. So y is greater than the line, i.e. x minus 2. And again, they're all solid lines, so I'm going to put an equals part as well. Okay, so they might ask you that. If you're to focus on anything, I wouldn't worry too much about this just in case, because it's more likely that they're going to want you to draw the lines and figure out where to shade it in, okay? So if you're a bit overwhelmed by this, just focus on, okay, I'm just going to draw the 3 lines and maybe see if I can interpret them, right? Don't worry too much about these past 2 questions because it's less likely that it will come up. Okay, so as I mentioned before, that is the higher tier topic only, okay? Inequalities regions is a higher tier topic only. It's probably one of the hardest parts of inequality, so don't worry if you're coming out of this and you're still not 100% with it. The bit that I obviously keep repeating that's the most important thing, we're not looking to get full marks, are we? We're not looking to get full marks in the maths GCSE, okay? We just want to get a decent amount of marks. So if you see this question, don't panic, don't just leave it blank. Make sure you're confident with plotting the 3 lines, because that is a skill that's in foundation tier as well, okay? So just make sure you're confident with that, and if you're really struggling with interpreting the region that we need to shade in, it might not be worth wasting your time trying to figure it out. So as I said, just choose a part to shade in the exam. Mostly I would say the triangle in the middle, but it's up to you. Make sure you can draw the 3 lines and you'll get 2 out of 3 marks, okay? That's already the majority. That adds up more than just leaving it blank, doesn't it? And then you've still got a chance of getting that right as well, haven't you? If you don't colour in anything, if you don't shade in anything, it's a guaranteed 0 mark for that part, isn't it? So don't leave any of it blank, draw the 3 lines and then see what you can shade in. The next video and the final part of inequalities is also higher tier only, okay? It is solving quadratic inequalities. Go and check that one out. You might actually find that's easier than this one, okay? So go and check that out. It's basically just a lot of factorising quadratics, okay? That's literally kind of all it is. So thanks for watching this video. I know this is a really tough topic to get the hang of. Don't worry too much, just do the best you can with it, and I'll see you in the next video.